Okay, question 2, we've got again another function that we need to consider, which is the f of x here, and we've got a show that which is only worth 1 mark, so that tends to make it a little bit confusing as to how much you need to show. But with show that's, as we've always recommended, be ultra conservative. You want to show as many steps as possible. So personally, this is the way I would approach this one. So here's my function on the CAS defined. I'll expand this function to make it easy to anti-differentiate. So there it is there, f of x equals this. I then let the calculator do my work, so I anti-differentiate the function. There's my terms there, and I let the examiners know exactly what I'm doing. So g of x is the integral of f of x, which leads me to these terms here. I then have the y-intercept occurring for the function of g at 1. So again, if g of 0 equals 1, therefore c equals 1, and therefore g of x is as required. So please, we show that. So I know it can be painful sometimes, but you need to show as many steps as possible. Okay, why leave doubt in the examiner's mind that you know what you're doing? Part 2, find the values of x, which the graph of y equals g of x has a stationary point. So remember, all I'm looking for are the stationary points, and f of x is actually the gradient of g of x. So really, I'm just looking at solving f of x equals 0, or I can literally just look at the function and use my intercept form and figure out that my stationary points will occur at -2 and +1. So that one's a 1 marker. I don't need anything more than just the answers.